Hello, sixth grade investigation 3.2 summary and variables and patterns. Again, now we have gone over graphs, we've gone over tables, we've gone over equations and different situations, and now we're going to put them all together. Okay, you can take, I like this visual because we can go from a graph to a table or a table to a graph. We can go from a graph to an equation. Okay, we can figure out equations to graphs, equations to tables, and then we can have a situation. So all of these are related to each other, and we can go from one to the other based on our needs. So let's start off with this idea. Again, there's something called rate of change, and we're going to use that to show us that we can go from a table to a situation to an equation to a graph. So here we're starting off with the amount of change in the dependent variable produced by a given change in the independent variable. So here we have different time in hours, okay, hour 0, 1, 2, 3, 4, and our distance for a speed of 60 miles an hour. So right there is our situation. We're going 60 miles an hour. Okay, so if I go 0 hours, okay, so basically I'm doing 60, okay, in each hour. So if I go 1 hour, I'm going 60 miles. If I go 2 hours, I'm going 120 miles. 3 hours, because again, each hour is 60 miles. For each hour, I go 180, and then I go 240 in 4 hours. Now here, I'm going a little bit quicker. I'm going 65 miles in an hour. So my first hour, I would go 65 miles. If I'm going 2 hours, it's 130. If I'm going 3 hours, it's 195. And if I'm going 4 hours, it's 260. So I've gone with my situation, okay, and I've gone from my situation to my table, okay? Now we're going to use this and go from my table to my equation. Write an equation to show how distance and time are related for the travel at each speed. So D is going to represent my distance, and T is going to represent my time. So in my first problem, okay, what did I do? Well, we were deciding our distance. We filled in our distance. So my distance equaled, I took my 60 miles and I multiplied it times 1 to get 60. 60 times 2 to get 120. So I multiplied my 60, but what changed each time was my time. So D equals 60 times time, or D equals 60t. Here, we had the same thing. We were looking for our distance at the beginning. We didn't know it. But what we did was we took our 65 and I multiplied it by my time. And each time it varied, so that's why t is my variable. So now we went from situation to table to equation. Okay, now we're going to go from a graph. And I'm going to go from my table to my graph in this situation. All right, so I'm going to slide this down. And again, time is on the bottom and distance is on my side. And my time is hours. And again, we're going up by 1 hour. And I'm going to go every other line again. I like to do that. 1, 2, 3, 4. And actually, I should label that this is hours. Okay, my distance is in miles. Now, even though I'm doing 2 different charts here, I still need one consistent scale. So I think I'm going to go up by 60s and go every line. 60, 120, 180, 240. So now I am going to, actually, do I need to go up one more? I need to, it's 240 and then 300. So now I'm going to plot the first one, which was 60, 120, 180, 240. So time 1, it was 60. 2 hours was 120, 180, which I just realized I made a mistake. No, I made a mistake here. No, I didn't. 120, that's an 80. If I could read my handwriting, that would be great. Okay, then 180. And then the next one would be 240. Okay, then I'm going to make a straight line. Make my ruler out. Make a lovely straight line here. I'm just going to go off and I will label this equation 1. EQ1. Okay, then the next one at time 1, it's 65. So this one's going to follow just slightly above. Okay, then 130. And here. And then here. And this one is a constant speed, so this will be a straight line also. And this one we will call equation 2. Now again, because they are at a steady pace, both of our lines are straight. Equation 2 is going to be a little bit steeper because we are going faster. Let's take a look now at the next page. So now again, remember that relationship that we can go from equation to table to graph, but this time, or graph to table to equation, this time we're going to start with our equation. For each equation, make a table of x, y values, the whole number of values from 0 to 5, then use your table to make a graph. So here's my x, y values. I'm using my whole numbers for x from 0 to 5. Okay, and for whatever reason, I skipped 4, but we're going to go with it. All right, so my equation now is y equals 4x. So that means wherever there's an x, I'm now going to substitute this number. So this becomes y equals 4 times 0. So 4 times 0 is 4, so that means y equals, 4 times 0 is 0. I'm doing really good on this one. And that's going to be 0. Okay, my next is y equals 4 times 1. Well, y then equals this side simplifies to 4. Okay, next one, y equals 4 times 2. So y will equal 8. Now you don't have to write this. I'm just showing you that we're using and we're substituting in for the formula. Okay, y equals 4 times 3. So y equals 12. And then y equals 4 times 5 because we skipped over, and y equals 20. Now in this table, it wants us to use y equals 2x. So now I'm going to do the same thing. 2 times 0 is 0. Y equals 2 times 1. So when x is 1, y is 2. When x is 2, there's my x I just substituted in. Y is 4. When x now becomes a 3, so I substituted the 3 in, y is 6. And when x is 5, y is 10. Right? So once again, now I'm going to go down and take my table and make it into a graph. So if we notice I have 0, 1, 2, 3, 5, I still on my scale down here have to include the 4, or else it doesn't, the graph gets messed up. So here's 0, 1, 2, 3, 4, and 5. Now here I think I have to go up by, if my lowest is 0, my highest is 20. I think I will go up by 2s. And just to spread it out, I'm going to go every other one. Okay, so now I'm going to do my first line, which when my x is 0, y is 0. So here I have 1, comma 4. Okay, so I'm going to go to the right 1 and up 4. And then I have 2, 8, 3, 12, and this time 5, and go all the way up, 5 and 20. Okay, I'm now going to connect this. And again, it is a consistent rate, so I get a nice straight line. And we'll label this one y equals 4x. Now you can't see that one too well. Okay, so now I'm going to go to this one. Okay, again, when x is 1, y is 2. So I have 1, 2, 2, 4, 3, 6, 5, 10. And I will make my line here. And that will be my line. And this one is y equals 2x. All right, so on this page, again, what we did is we now took an equation, went to a table, and showed that you can go to a graph.